Hello and welcome back to the Diabolo tutorial series. I'm Michael and this is part 9. Well, today we will create a zoom feature for our character and we will create a rotate feature so we can rotate around the character. So double click on the Diabolo card blueprint and we will have our previously created combat system. Now go to a free space and right click and type in wheel up, mouse wheel up, and select it. Then right click again and type in mouse wheel down and select it. We will basically use our scrolling wheel to zoom out and to zoom in. Now we will use our camera to zoom out and zoom in. So drag our spring arm component into the event graph and put the spring arm in between these two nodes. Now drag out from the blue pin and type in get target arm length and select it. This will basically give us the offset from our origin to our camera up here. So if we increase the target arm length, we will zoom out. If we decrease the target arm length, we will zoom in. So we will first set up our zoom in feature. So drag out from the blue pin of the spring arm component. Then type in set target arm length and select it. Now we want to decrease our current target arm length. So we drag out from the green pin, type in minus, and we select the float minus float. We will type in something like 20, and what basically this value means here is how quickly do we need to transition from our current position to a new position. So a higher number would decrease our target arm length much more, and we will have a higher zoom in speed. So just connect this, our pin here, to our target arm length, and we will not connect it right now, because we want to set a minimum value where you can zoom into. So if we have the spring arm length of 1000, we maybe just want to zoom in until we hit the value 400. So I will right click here, type in if, and select the branch node. Now we will connect the pressed to the branch node and the true to the set node of our target arm length. Now we just need a condition. So we drag out from our target arm length, this green pin here, type in is higher or is more than float, and we will type in 400. So as long as our target arm length is above 400, we will decrease our target arm length and zoom in. If it is false, nothing will happen. Now we will do the same with our mouse wheel down. So we can actually copy the branch, the set, and yeah, just these two nodes, copy them, paste them, and connect them up. The press to the branch node and the execution pin is still connected to the set pin. But we lost our connection to our spring arm. So left click on our blue pin here and drag it to our set node and connect it to the target self. Now we will drag out from the target arm length here, and we will type in is less than float. And we will this time around type in 1000. Because we have our default value on 1000, we don't want to exceed this limit, and this will be our maximum zoom out value. So plug this into the condition node of the branch of the mouse wheel down and drag out again from our target arm length. Type in plus and then select the float plus float. We will take the same number as above here, so we will input 20 and we will connect the green pin to the target arm length down here. We compile it, save it, and we will try it out. And it works. Wonderful. You can always input a higher value here, and if you want to actually not control it with this here, like always typing in 20 or 30 or 40 in these two, we can also create some kind of a variable. Just drag out, select promote to variable and type in zoom in and out value. Or no, zoom in and out value, zoom in and out speed. And we can type in on the right panel here something like maybe 30 or 20 or anything like that. Drag it out, select get, or you can just connect our newly created node with a node down here. Just connect the zoom in and out speed to the second value of each of these two nodes. Okay, that's way easier to do it. You can also make them individually. So if you want to have a separated zoom in speed and a separated zoom out speed, but I think you are smart enough to figure that out, because it just means that you need to create two variables instead of this one. Okay, let's see if it works, and it still works. We will let the default value on 30 in here, and we will now continue on and create our rotate feature. So which button do we need to use? I think I will use the middle mouse button to do it. So right click, type in middle mouse button and select our middle mouse button. Okay. The next thing we want to do is to have something called a gate. So right click, type in gate and select gate under flow control. What a gate basically does is that something enters into it, like maybe event tick or any different thing, and it's like a valve. You can have an event or a function or anything like that open up our gate, and it will pass any information which comes into our enter node through out in the exit. So it opens our exit node here when we open this here. We can also close this valve-like node. So if we close it, the exit will not fire anymore. So that's a cool way of controlling stuff which needs to pass through and where you want to stop things being transferred to the exit, and the chain after this that can prevent it from activating. Okay, so we want to actually create something like a rotation based on the drag direction. So if we press the middle mouse button down and hold it down, we can drag our mouse to the right direction or to the left direction, and it will move accordingly or rotate accordingly. So in order to get our screen position here, we right click, type in mouse X, and we go under mouse events and then select mouse X. This will spawn this node here, and this just basically provides the screen location of our mouse here just on the X axis. So get this thing up here above our middle mouse button, get our gate up here, and connect the mouse X execution pin to the enter pin. Now the next thing we want to do is to actually open or close things. So if we press the button, we want to open it. If we release it, we want to close it. So what now? What after the exit? Well, we have an axis value return value here. And this means all things above the X will be on the right side. And all values below 0, like minus or negative values, will be on this left side. So we drag out from our axis value, type in is greater than, and then select float is greater than float. We will go to our axis value again, drag out, type in is less than, so float is less than float, and select it. Now we have these two nodes. But we need a condition. So right click, type in if, and select our lovely branch node. Connect it with the exit node. And the first condition we want to check is mouse X greater than 0? And 0 basically means here in the axis value that our mouse X is in the middle. So we plug this into the condition pin. Now we can actually just input our opposite rotation into the false node, but the problem is if our axis value is greater than 0, our true will fire off, no problem. But if it is false and we are on 0, the false will always repeat and repeat over again and actually try to rotate our rotation to the left side. And we don't want it. We want it to be still if we actually are on the 0 value here. So we will use another branch node. So select it, copy and paste it, and connect our mouse X axis value is less than 0 to our condition pin on the branch. So now we will connect the false statement to our branch statement because we want to check if we actually rotate into the opposite direction, if our axis value is not above 0. And now we will implement our rotation, our nodes. So go down to our spring arm, drag out, go up here and scroll down and select add reroute node. What this basically does is it spawns a blue node with no name on it. And that's basically because this is actually like a link. We can actually use this to get our spring arm down here. So it's distributing our node execution, our node blue pin, just in a different location. So that pin is the same as this pin here. We will just comment it by just dragging around the blue pin and then press C so we can get this comment, and we will type in spring arm reference. Oops. Spring arm reference. If I could spell today. Spring arm reference. Like this. Now we will drag out from our blue pin here and type in set world rotation and select the set world rotation node. We will drag it up here and we will copy it and paste it down here. Now we lost again our connection of our spring arm. So just go to our spring arm reference and connect it to our target self on the set world rotation. The next thing we want to do is to actually get our current spring arm world rotation, so we can add to it instead of just typing in a random value. So drag out from our blue pin here, type in get world rotation and select the get world rotation. Now get it up here and we will set it in between these two, like this. Now the last thing you need to do is actually right click on the new rotation up here and select split struct pin. What this essentially does is that it takes our rotation, our full rotation, and just splits them out as single values like our roll, our pitch, and our yaw rotation. So we can actually specify what from this rotation we actually want to modify. We don't want to use the whole rotation or modify the whole rotation, so we need to do it. We just want to update our yaw rotation. So do the same down here, right click, split struct pin, and on our get world rotation we right click on the return value and split struct pin. Connect the roll up to this roll and this roll, the pitch to this one, and the yaw on this one. No, the yaw will not be connected right now. What we actually want to do is to actually add or subtract to our current value. So we drag out from our return value z, yaw, type in minus, and select the float minus float. We will use this one down here. So drag it down and type in something like 10. Connect it to our yaw new rotation z down here and drag out from our return value z, yaw again, and type in plus, float plus float. Now type in 10 and connect it with our yaw up here. Connect now the true to our right rotation and our true here with our left rotation. Now, because we have a fixed value down here in zoom in and out speed, we want to have a variable 2 up here to actually, well, just type in something and our rotation speed will actually be applied on both of them. So we go into the left panel under add new, then click variable, and then name it rotation speed. Go on the right panel, click on variable type and select the float. Now we will have our rotation speed selected, and on the right panel under default value we will type in 10. I changed my mind. I think we use 3 to not get a too quickly turning camera. And now drag our rotation speed out, select get, put it under the get world rotation, and put it into the 10 value here, and this rotation speed on the subtract 10. Okay. Yeah, this was it. That should work like a charm, but we will not know if we don't try. So press play, and I press the middle mouse button, go to one side, to the other, and we're actually rotating. And if we release the middle mouse button, it's done. It doesn't work anymore. So that's a very, very handy feature. So now you could think, okay, yeah, this rotation is a little bit fast. So you can always go into our spring arm, click on it in the left panel here, go under leg or under the leg tab and change your camera rotation leg speed to something lower. Or you could also lower your rotation speed if you want to. So I hope it was helpful today. I wish you a wonderful day, a wonderful evening, or whatever. And I hopefully should see you next time. Goodbye.